Did you know that shoelaces are an intricate example of mathematical patterns in everyday life? Shoelaces may seem like a mundane part of our daily attire, but they hold a fascinating secret: mathematical patterns. From the intricate weaving of threads to the precise tension of the knot, shoelaces showcase a wide range of mathematical concepts. Mathematicians have studied shoelaces as a model for understanding complex systems and patterns. One of the most striking patterns in shoelaces is the Fibonacci sequence. Did you know that the number of threads in a shoelace follows the Fibonacci sequence? This sequence, where each number is the sum of the two preceding numbers, is a fundamental pattern in mathematics. The Fibonacci sequence appears in the arrangement of threads in a shoelace, creating a beautiful and intricate pattern. But that's not the only mathematical pattern in shoelaces. The tension of the knot also follows a mathematical pattern known as the golden ratio. The golden ratio, approximately equal to 1/618, is an irrational number that appears in many natural patterns. The golden ratio is present in the tension of the knot, creating a stable and secure fastening system. Imagine a shoelace as a representation of a mathematical equation, where the variables are the threads and the tension of the knot. This equation, known as the shoelace equation, is a complex mathematical model that describes the behavior of the lace. Mathematicians have used the shoelace equation to study complex systems and patterns, such as the behavior of materials and the movement of particles. But what about the physical properties of shoelaces? The material properties of shoelaces, such as elasticity and tensile strength, also follow mathematical patterns. The elasticity of a shoelace, for example, can be described using the Hooke's law, a fundamental principle in physics. The Hooke's law states that the force required to stretch an object is proportional to its extension. But that's not the strangest part. Did you know that the knot in a shoelace can also be described using mathematical concepts? The knot in a shoelace is an example of a mathematical concept called a topological invariant. The invariant is a knot in a property of a shoelace is a shape that remains topological invariant because it unchanged under remains the continuous same even when the lace is stretched or transformations. The invariant is a knot in a property of a shoelace is a shape that remains topological invariant because it unchanged under remains the continuous same even when the lace is stretched or transformations manipulated. Imagine a shoelace as a representation of a mathematical concept where the knot is a topological invariant. This concept is important in mathematics and physics because it helps us understand complex systems and patterns. But what about the impact of mathematical patterns in shoelaces on our daily lives? The mathematical patterns in shoelaces may seem trivial, but they have a significant impact on our daily lives. The precise tension of the knot in a shoelace can affect our comfort and stability while walking. A poorly tied knot can lead to accidents and injuries. Mathematical patterns in shoelaces also have practical applications in engineering and materials science. The study of mathematical patterns in shoelaces can help us design new materials and systems that are more efficient and effective. In conclusion, mathematical patterns in shoelaces are an intricate and fascinating topic that showcases the beauty and complexity of mathematics. Mathematicians have studied shoelaces as a model for understanding complex systems and patterns. The study of mathematical patterns in shoelaces has led to important discoveries and applications in various fields. So, the next time you tie your shoelaces, remember the intricate mathematical patterns that are at play. Subscribe to our channel for more interesting stories about the intersection of mathematics and everyday life. And don't forget to like and comment below if you found this fascinating. Thanks for watching.